Well, so why don't we just start? Let's just do this. Thank you all for coming. We're going to have a kind of an informal conversation here. We have Bryce Payne, who is a soil scientist and a PhD, who has done a fugitive emissions study here in Manhattan. We'll be talking about what's going on with methane and why that's such a big problem. Buck Moorhead is an architect, and he's going to, so we're going to start with what's the bad, and we're going to move to hopefully what's the good, which is fixing up homes so we have a whole lot more energy efficiency, and dealing with the architectural issues around how to take care of us and make it more efficient and sustainable. Regina Cornwell is the woman that the two of us have initiated this talk, and she is a curator.
Go ahead.
And she'll talk about herself then, yes. And I'm an artist, but I'm also an activist, and I'm also a real estate professional, so I have a number of different perspectives here on what we're going to be discussing. I think what we could do is maybe start with what you're wanting to introduce, and then we'll just kind of move into the path here from what's really difficult and hard to address and very dangerous into what we can actually deal with. Samara Swanson, who is the New York City attorney, well, the attorney for the New York City Council's Environmental Committee, and she is going to be speaking as well. I don't see her here yet, so maybe because of the room changes, she'll get here. But she's an actually very amazing speaker too, and there are very important things happening with the New York City Council that I think will be very inspiring.
Thank you all for being here, and we want to make this as informal as we can. So unfortunately, I'm still going to have to read some of it, but I will not read all. But I want to make three points that are interrelated. First, what it means to be here now for the climate weekend, how it encompasses global warming, how all encompasses global warming, though it is often forgotten and we think mostly of energy, and how global warming forces us to change, and this transformation is ultimately positive.
And you're next, Bryce. Bryce Payne, who is the scientist who's a scientist who's been doing a lot of work on fugitive emissions and everything.
I don't know about the everything. First of all, bear in mind I'm a scientist and I'm always cautious.
Yeah, I'm sorry, I'm just...
Go ahead. I'm always cautious about these kind of things to never put up any numbers and never put up any graphs.
No, we like graphs.
And if you're a scientist and you can't put up numbers and graphs, you're really severely hollow.
Well, we're going to go up here.
Yeah, let's get the microphone over here.
Half the language of science is lost at that point. There's something being passed around. I'm not sure there's going to be enough of them. And the reason I had that passing down, I didn't know how many were going to be here, is because I'm going to go through these really fast. I got a series of slides. I'm going to move through them very quickly. And I thought maybe those things might be handy if you want to jot down notes or questions as I go. That way, if you want to back up later or questions you don't want to lose track of. All right, so I've kind of been introduced already. I want to mention some other people right quick. Bob Ackley, who I work with at Gas Safety, Inc. What our relationship is basically, he does the field measurements and I do the data handling. I process the data and analyze it, and he sees to the machinery. And it makes for a good pair so far. I also have a developing relationship with Wake Forest, the Center for Energy, Environment, and Sustainability there. And there are a number of scientists I should mention who I've been in contact with to prepare this thing. Steve Monsack at NOAA, and NOAA in general. And you're going to see some documents when you go through, and then there'll be a list of things at the end that if you want to ask about, you can, in terms of publication of other authors. Okay, so very quickly. Methane is an odorless, colorless, tasteless gas. Sounds like a scientist talking, doesn't it? About half as dense as air. It's explosive in proper mixing ratios. It is asphyxiating, and it is a potent greenhouse gas. It's the smallest hydrocarbon molecule. Hydrocarbons are the compounds that are primarily present in petroleum. Its chemical formula is CH4, meaning telling us that each molecule contains one atom of carbon, 4 atoms of hydrogen. It occurs pretty broadly in nature, wherever organic materials are present and oxygen is not. There are two main pathways for its production. One is biological, the other is geological. The geological version is called thermogenic. Not that you need to worry about that, I'm never going to say it again today. But the biological pathways are ones you're probably all familiar with. Animal insides, swamps, sewage systems. The geological pathways are fossil fuels. And I put this out, I don't want to spend too much time on it, and I don't have a pointer. And I'll try. How can we, let me see if this will work. Is that coming up?
Yeah.
Ah, there we go. Okay. I don't want to spend a lot of time on this. I want to show you a couple of things. We're here to talk about methane. That green line right down there, methane, is radiative forcing. Don't worry about it. It's in watts per square meter, but what it really is a scientific way of getting units on the impact of gases, their concentration in the atmosphere, on the amount of global warming that's occurring. So you can see methane's contribution down here appears to be relatively low. Then you have CO2. This red line here is the sum of methane and all the ones below it. And one of the things happened in recent years with methane is its rate of increase in the atmosphere has somewhat leveled off. In the last several years, it started increasing again. But you can see what's happening with CO2. It continues to increase, and I'll talk to you more about that in a minute. The important thing here on this slide is this right here. This is when you add up all the greenhouse gases, you get this one. And this is now, and this is projecting into the future. And I just want to say to you, this is what they expect to happen if we have an 80% cut in greenhouse gas emissions, all of them. An 80% cut over the next 30 years. Imagine what will happen is we'll stay at this level and it will eventually curve back down so that by 2060, bear in mind we're talking 50 years from now, by 2060 the level will drop back down to about the equivalent of 475 ppm of CO2 in the atmosphere.
Oh, God. That's at 80%.
Pardon?
That's at 80%.
That's if we do an 80% cut over the next 30 years.
In everything.
The reality isn't even on here. Nobody wants to see it, I don't think. I've looked many times at what would a graph look like if we really looked at what's likely to happen. Because our actual CO2 emissions rate is increasing 1 to 3% per year. Our methane emissions rate is increasing, and we don't see that it's going to stop. The momentum in the system is such that it's not going to stop. And so what you end up with, instead of that A line right there, is what they project if things stay at constant levels right now. That is to say, we don't get any worse, we just don't do any better. Then that line will project along that A pathway. If it goes along the way that it looks like it's really going to go, that A pathway is going to curve up. This is sort of the magic number right there. Is that 500 ppm CO2 equivalent level is considered the point at which we have an irreversible 2 degree centigrade increase in global average temperature, which is the supposed threshold where we don't come back. And you can see that we are in essence there. We're here right now.
Where? Oh, where that line is.
And if we go out 5 more years at this rate, we will cross that threshold. So let me move on because I'm taking too much time. Now, as a scientist, what I get continually disturbed by on these things is we need the voice of reason. Scientists really like the voice of reason. The difficulty is that this has turned into what I put up here, a battle royale. It's the fight of the century. We have these silly arguments of the 97% versus the 31,000. I'm sure you're all familiar with the petition of the 31,000 scientists who said, no, climate change is not real, and the 97% of climate scientists who said, yes, it is real. And so we end up in this ridiculous back and forth discussion. From my perspective as a scientist who's concerned with the natural world, that to me just seems like, God, we got to stop wasting our time. And what Earth is doing and what we think about what Earth is doing doesn't make a hill of beans of difference. What we say about it and how much we fight about it doesn't matter at all. What matters is the Earth is going to do what it does. And unfortunately, we need to fit in that. And what matters is what are we going to do. So, I'm sure most of you are well aware of Walt Kelly and Pogo years ago when he said we had met the enemy and he is us. Everything we do depends on fossil fuels. I mean, everything we do. We're addicted to it and we cannot stop using it. No matter how much you want to think, you're in this room, every second you're in here, fossil fuels are being burned to allow you to be here, to get you here, to feed you when you get out of here, to process the water that's going down the drain of the bathroom, to get the water into the bathroom, everything. I put this up because scientists like graphs. The point here is, what I wanted to show you is there's this inevitable trap between human population and carbon dioxide emissions. The red pluses, which you can't quite see on here, are human population growth. The gray circles are carbon dioxide emissions over the same time frame. The red line and the black line in there are the linear regression lines over those two data sets. You almost can't see the red line because it's exactly the same for all practical purposes as the black line. They track each other perfectly. The implications of that are rather dire because we know the human population is going to continue to increase, and if we don't break that connection, there is no getting out of this, the continued increase in carbon dioxide emissions. Okay, we're at it. We got to stop. What can we do? We've got multiple greenhouse gases. What can we do? And so the answer to that would seem to be, well, don't try to cold turkey all the gases at the same time. Don't try to get off CO2 at the same time as you try to get off of methane, and try to get down nitrous oxide and all the others. It's a challenge. It's a bridge too far. So what can we do? And I put that quote up because I just really like it. But the point is here, we have to understand what we are doing, and we have to understand that particularly with respect to greenhouse gases. And what greenhouse gases are the most important? What do they have? Which ones have the most impact? Dominant greenhouse gases are carbon dioxide. Presently, about 65% of human-related radiative forcing is due to carbon dioxide in the atmosphere. The next is methane at about 17%. And the third is nitrous oxide, at about 6%. And those numbers will change a bit, which I'll see later, but basically carbon dioxide is the big one. Methane is the next one. And you would think, well, why not go after carbon dioxide? It's the big one. Because what is done cannot be undone in a certain sense. Whereas methane, once it gets into the atmosphere, lasts about 12 years, 9 to 12 years. You could say 10 is a reasonable number, but I put around 12 years here. And I could explain to you why it varies, but...
Can you tell us what happens? How does it break down?
I'll tell you. I'll tell you what, let's do that as a question. Then we have carbon dioxide and nitrous oxide. Both of them, once they're in the atmosphere, last more than 100 years. About a third of carbon dioxide will last somewhere between 10,000 and 10,000 years. So once you're in with carbon dioxide, you're in. It's in the game. You're going to have to live with it. Pardon? Once you've got methane in the atmosphere, you can do something. In 12 years, it will go away. So if you stop emitting methane now, that accumulation of methane that's going to impact the next 12 years won't be there. So then the next question comes up is, well, which is which and how much difference do they make, and how much more potent is methane than carbon dioxide? It depends on the time frame, because once carbon dioxide is out there, it goes for a long time. Methane, on the other hand, is more potent, but doesn't last as long. And the way that they've come up to compare these things is something called global warming potential. And if you look at methane, then we need to choose a time frame in which to make a comparison. So if we compare over a 100-year time frame, which is the norm, it's typically used in climate projections, then 1 kilogram of methane is comparable to, or is equal in effect to 34 kilograms of CO2. But, bearing in mind that methane is a short-lived compound in the atmosphere, if we take it back down to a time frame that's relevant to the lifetime of methane in the atmosphere, that number changes dramatically. So if you get down in the range of 10 years, which is about the lifetime of methane in the atmosphere, the impact of each kilogram of methane is about 100 or more of carbon dioxide. And so the thing of it is we ought to be using that to our advantage. So if we plan, and the important thing here is and act in shorter time frames, then eliminating 1 ton of methane emissions is the equivalent of eliminating 100 tons of carbon dioxide. That not in the sense of we can take it out of the atmosphere, we can't. But if we don't put that ton of methane in, it's the equivalent of having not put 100 tons of methane, of CO2 in for that 10-year period. So, if you want to take this approach, there are some risks involved. And one of the risks is inadequate or inadequate information. If we plan on a 10-year time frame and we fail to act, or we act in a manner that we should not, we make a mistake in terms of what we're doing in trying to cut methane, then every ton that we fail to reduce emissions by becomes the effect of an additional 100 tons of carbon dioxide. So you've got to be careful. The second risk is the advantage only lasts 10 years. What we're going to do is, with those curves I showed you, we're going to pull that curve down for 10 years, and then it doesn't matter anymore. It's going to go right back where it was going before. So if we're going to do something with those 10 years, we're going to make use of them at the same time that you pull that methane down. You need to be working headlong into how to reduce carbon dioxide emissions and start doing it. How to is the big question. We are utterly dependent on fossil fuels and carbon dioxide emissions. How to get that down is important. We need time to work on that. And methane is easier. In terms of getting quick reductions, we can do it quicker with methane, and in many cases we can actually, where it can be done in industry, can probably make money in terms of, if they don't waste that methane to the atmosphere, it is a saleable commodity. CO2, on the other hand, is relatively worthless in comparison. So our big opportunities are in the fossil fuel industry, virtually all phases, in waste management, sewage treatment, and landfills, and in agriculture. There are perils, and I've already mentioned them, with regard to doing a methane emissions reductions approach. One of them is you don't do the right ones. You don't pick the right methane sources. If you pick the wrong ones, you're picking the small ones, your impact is not as great. And the other is you're simply not aggressive enough. If you're not aggressive enough, even if you choose the right sources, you won't get enough reduction to buy any time. How do we exploit the opportunities and avoid the perils? We have to have accurate, reliable knowledge of the sizes, numbers, locations, and properties of the methane sources, which we do not currently know. And so our real problem currently is when you see these things like these curves I put up before and government documents and various and sundry reports, anytime you see the word inventories mentioned in a footnote or somewhere else, that means they didn't measure. Those inventories are based on estimates that are based on typically other estimates that somewhere back there, somebody made a measurement of something and they extrapolated to everything from that measurement a long time. And in many cases, the data, when you look back, was not very good. Information developed that way is unreliable, and as I've already mentioned, almost none of those are based on actual measurements.
Is there examples of sources you could list, a few examples of sources of methane you're talking about?
Well, ask me at the end. Let me run on through this. Okay, so the examples of the kinds of things you see in terms of numbers. If you look online right now, you can find the 2000 to 2009 period for methane emissions as CO2 equivalents. They take the methane, they multiply it by the GWP, the global warming potential, they come up with the methane equivalent. Look at the 2005 to 2009 time frame. The EPA says that we were relatively stable around 600 million tons of CO2 equivalent per year. Their position was that agriculture is emitting more than fossil fuels, that fossil fuels related emissions are decreasing, and that agriculture related emissions are increasing. At the same time, the Energy Information Administration, for the same time period, said we started at 670 million tons per year, and over that time period arose to 730. And they said that fossil fuel related emissions were larger than agriculture, and that both were increasing.
Was that based on the 100-year or the 20-year?
That's on the 20. The 100-year, those numbers get bigger. Then the DOE, National Energy Technology Laboratory, did a completely separate assessment. And you can see this is done a bit differently, because this is done in terms of total natural gas produced and methane emissions as a percentage of that total natural gas produced. And the number that's
greenhouse gas or natural?
Natural gas.
Natural
Natural gas production. This is for natural gas production operation. What they come up with is that the fugitive plus point source losses, which is basically things you can do something about right away. The others of these they list on here are consumptions. They burn fuel. They burn some of the natural gas to run things. But if you just look at their fugitive and point source losses, they're somewhere between 1.8 and 4.8%. If you take 100 to 1 equivalent of methane and carbon dioxide, that means if you lose 1% of the methane in a natural gas operation, you lose 1% of what you're operating on, you've already crossed that CO2 boundary. Because the CO2, the methane you lost already equals the energy, the value of all the CO2 that's in the rest of the gas. It's actually going to go to market to be sold. And the fact of the matter is, we're losing 1.8% just without question. It might be as high as 4.8% according to this particular study. There have been about 15 published peer-reviewed papers in the last 3 years or so on the same subject, and you can see where the numbers come up. Of those 15, 3 said they were less than 0.9%. 2 said they were somewhere between 5.5 and 9%. Even if you're in the middle, we're still out of range. We still can't sustain this. The methane we're losing is as bad as or worse than the CO2 that's going to be generated from burning the natural gas itself. So you're doubling the load. And if we come out of this, who should we believe, why, and what should we do? And I just threw these up here. You can pick any one of those that I just put up there. If you want to take any one of those as your authority, then you're going to make a different decision about who to go after. Are you going to go after agriculture? Are you going to go after fossil fuels? Are you going to go after fuel transportation systems? What do you do? And right now, we don't have enough data to know. We need it quickly. There's a third risk, which I call delusions. Bridge fuels and golden ages. And that has to do with unconventional fossil fuel development, the methane that's coming off of those things, methane hydrates, permafrost melting because of warming. There's just a lot of stuff in there. And we're failing to recognize that we are setting up the potential for large new emissions associated with warming. But something we can actually do something about is associated with processes like fracking. We may be setting up new geological pathways so that even when you think you've exhausted those shale gas reservoirs, there's enough there so that over time they will continue to release gas. And even if you plug that well, if secondary pathways have been established by the fracking process, that gas is now going to find its way to the surface, and it's going to do it basically forever in human terms. And so I'm going to jump down to the last one, which I call acting without knowledge. It's a failure to look before you leap. The science should have been done on these things before we started pushing down these roads. It never has been. Humans don't operate that way. We come up with a new chemical, we find a way to use it before we determine what that chemical is going to do to everybody else. The same with fossil fuel development. In every case, if you find a coal vein, you mine it. If you find an oil deposit, you drill it. If you find shale, you frack it. So the only way to get out of this is an adequate understanding of methane sources and emissions and rates based on actual measurements, so we really know what's happening in the world. We've been doing some with the support of Damascus citizens. We're trying to develop a relationship with the City College of New York and Wake Forest. What we've done so far, we did the study that you see some of the results up here on the wall. Gas Safety did this with Damascus citizens, and our measurements, just a one-time effort, we've interpreted those to mean that, to indicate that the leakage in Manhattan is somewhere between twice and 10 times as much as the industry and EPA estimates. Our measurements are all methane of all sources, but the predominant source of methane in New York City is the natural gas distribution system. We've gone into the drilled Marcellus Shale area. We find extensive areas there. We have elevated methane levels, meaning there's gas leaking to the atmosphere there. We've been down to the Barnett Shale area in Texas, and the geology down there is trickier, but there are emissions there from natural gas, primarily finding its way to the surface through the groundwater. Here's a list of some other researchers that have looked at this thing in different ways, and at that I'm just going to say thank you and try to stop this so I run longer than I should have.
It's very okay.
Somebody out of this. There.
Okay, great. The way we've set this up, or hope to set this up, is that we're going to have just brief talks first, and then we can go to the questions if that's okay. Although I hope you can write them down so you don't forget what you want to
Yeah,
ask
it
about.
just lets you forget
Is
things.
that okay?
Do you need paper or something? I brought cards.
And then it's on the screen.
Yeah, I mean, I think that, what Bryce has just brought up is such a huge, huge conversation. We'll do the best we can in the time frame we have here. I'm going to be talking about activism and how that actually has been very helpful for us. I want to say thank you all for coming here. I really appreciate your interest in this. And we all need to participate, and that's just such an important thing. In 2008,
I just say, if anybody has questions, they don't want to, say them or something, and they want to write them down, you're welcome to do that. I can pass these out, or if you need to take notes or something. Would anybody like a card to write questions on? You're welcome to them. I'm sorry to interrupt.
okay, no problem, yeah. So, back in 2008, a really good friend of mine said, hey, have you heard about fracking? And I said, no, what's that? Well, turns out I actually learned a whole lot about it, a lot more than I ever thought I would be involved with. And I have to say, activism is a lot of work. It can be disappointing, but it can be incredibly rewarding. And, in this process, I have met some incredibly amazing people, and people who have been really dedicated to working on this, sharing information, and like what's happening here in this talk. To deal with climate change issues and other levels of damage that are happening on the Earth, working with other people is a really great support system. And as a friend of mine also says, DIY, you do it yourself. Advertisements of natural gas, shale gas, which is largely methane, by the way, just so you know, methane is about 87 to 93% of what the content of natural gas is, right, Bryce?
It's actually more like 85 to 99% raw, and commercial gas is about 50 to 93% now.
Okay, good, so now.
Right.
Yeah, but anyway, natural gas is not clean. From the moment of going from extraction all the way to use, there are incredible health impacts. Children in fracking regions are getting birth defects now. Studies have shown that. Gas leaks in the Bakken fields up in North Dakota, and let about 35% of the gas leak every year. that's either leaked or vented or flared. Depletion rates are very high. In 2 years, the wells are losing almost all of their gas. They have like 15% of the gas left from the initial production. We can talk about this more later, but I really wanted to bring up that we've been told the gas is clean because it emits 50% less CO2 when it's burned. More than, like less than coal or oil. But it does not take into account the other higher methane emissions that happen on the soup to nuts process. Even then, the burning reduction emission is not enough or less to slow down the global warming, which Bryce has just mentioned. Further, they say shale gas does not have the particle matter of coal and oil. But again, there are these minuscule particles emitted when gas is burned that are not measured. And they're ash-like scales like breathing cigarette smoke. This is something that's not commonly known. It's dangerous and ignored, and may be suppressed information. Finding out this information is the kind of step for involvement. Your being here is a step. Activism in New York, I don't know how many of you are from New York, but New York has been an amazing activist state. A lot of grassroots groups have been working very hard to protect their homes and the surrounding environments that are generating that maintain our life. There are over 100 groups working to oppose fracking. Towns have banned it, towns have had moratoriums, and they've won lawsuits on their side. Much of the grassroots efforts have been so deeply informed that they've held off hydrofracking for at least 6 years. Right now, by the way, the moratorium has expired, but there hasn't been any further action yet. Many informed scientists have been providing information about the problems and disasters, and they share information with the grassroots groups. I'm advocating that everybody can participate in addressing climate change in some form. Obviously, you can join an organization. Many of you are already here. You contribute money, contribute your time. Tell your friends about these talks. Damascus Citizens for Sustainability has an incredible website. That's the group I'm working with. I'm also biased, but it actually has an incredible website. EcoWatch and Think Progress are also very good sources for information about what's going on with environmental news and hydrofracking. There are a couple of examples of activism. Back in the day when I was just learning about this, I asked the Wes Gillingham from Catskill Mountain to come over to our home and talk to the people in upstate New York about what was going on in fracking. And we've been laughing about this since, because it was the only living room production that he ever did, the only presentation, excuse me. But it was really, a lot of fun, even though there was a 5-foot deep snowstorm that was happening we had to go through. Damascus Citizens members Joe Levine and Al Appleton spoke to the New York City Department of Environmental Protection back in 2010 to tell them that the water that comes to New York City, that comes out of the Delaware Catskill watershed, was going to be damaged and contaminated if fracking occurred in New York State. Because of that, in conversation they had, the DEP supported a study written by the hydrogeologists Hazen and Sawyer, which detailed significant potential for the reservoirs upstate and how they would be damaged by fracking. This water, for us, brings water to 15 million people. The Supplemental Generic Environmental Impact Statement, also called SGIS, changed to include a 2-year moratorium for the New York City watershed after that conversation. Fracking isn't held in New York due to the health impact reports, and Pullman doesn't want to deal with it until after the election. The grassroots group, Concerned Health Professionals of New York, have produced a compendium. It's a compilation of over 70 pages of studies and information about health impacts, and they also include climate impacts. All of these actions happen because somebody says, we need to address this. And they took the responsibility for preparing information and giving it to the government and sharing it with people, neighbors and friends. Working in an environmental group can be very effective. Another activist project was when my friend Rebecca Smith and I fundraised to do measurements of fugitive emissions of methane in Manhattan, working under the auspices of Damascus Citizens for Sustainability. This is the study that Bryce and Bob Ackley did, gas safety. They actually rode around Manhattan for 6 days, 5 days, and took measurements of these things. And what happens is, ground level, and there's another, if you go to the Damascus Citizens website, you can see there are 6 images of the fugitive emissions. And what happens is, these actually show you how much of a spike this is. The ground level is right here. The 6th emission, which I don't have on this particular photograph, actually shows what it looks like when you go out of the city. And the methane level is just way down low. So the difference between what's happening in an urban situation and the rural situation, or out of the city situation, is incredibly different. And these spikes right here have gone up to, I think the highest one was like 99 parts per million. Much of these are like, 10, 15, 20, 30. They're not considered to be explosion levels, but, it could also. You can't say it wouldn't. So,
San Francisco.
yeah, there you go.
What's the source?
This is probably mostly leaks from pipelines. They drove a car around with a little machine that actually tests. And by the way, these machines are rather new developments because they didn't really measure those really delicate, kind of small amounts of methane. The gas companies don't do that because it's not explosion levels. So what this is a different kind of explosion. It's climate explosion.
This is part of climate scientists who study the Arctic ice. There's a massive cloud of pollution coming off of the North American continent,
Yeah.
warming the Gulf Stream.
Yeah, we can absolutely talk about that next. So keep that in your question level because this is another huge problem here. What I want to say is, oh, by the way, and part of the activism in this, which was really, really cool, is that Becca and I were able then to turn this into an art exhibition. We're both artists. And we got a grant, worked with Cooper Union, and did a big exhibition and a panel discussion about what was going on with this problem of methane emissions. And by the way, this is happening all the way across the country. It's happening all the way across the world. It just hasn't been measured that much. This is the kind of information that has not been widely looked at or seriously looked at in great detail yet. These are successes, but these are not resolutions. There is so much more work to do. And back to the New York City Council hearing that Regina just spoke about. This was an incredible talk, and Al Appleton, who is the former head of the New York City Department of Environmental Protection, spoke. And his video is on Environmental TV, by the way. If you look up Environmental TV website, this about 10-minute talk of his is now available on that.
It's on YouTube.
It's on the YouTube, yes. Okay, this is what he did. He spoke about climate change. He said this is not pleasant stuff. It won't be a pretty future. But global warming we are having has come about by the success of having the luxurious life we have now. Now we are being asked to do the hardest things we can do, which is to turn our backs on industrial success. Turn our back on the industry that makes $600 billion a year. We will have to turn our back on what we are accustomed to. The approach should not be to try to mitigate or adapt climate change, but to adopt ways to stop fossil fuel, to stop ways to stop climate change. One way is to stop the subsidies and the exemptions for fossil fuels. They are huge. We need to change our energy policy. If we're going to deal with this, we're going to have to manage this ourselves. We can't just sit back and wait for whatever's going to happen. The real question is how fast can we convert to carbon neutral? It's economically feasible. We will save hundreds of millions to even billions of dollars, even in New York City, just that. The whole argument for sustainability is that if you quit wasting environmental resources, this would be a really positive thing. We can use the wealth of environmental resources. we can create a new and green economy, which would be better for the environment and the people. We can create a new world, and it would be exciting. Thank you.
Now is the question.
Oh, we have, Buck is going to speak, and then Samara Swanson is here too. Do you want to go next? Where does she go? There she is. Do you want to go next, or do you want to go next?
Where do you want that set? Take my lotus from you guys.
Why don't you go next, yes? Okay, Buck Moorhead is an architect, and he's going to be talking about the energy efficiency.
Okay, so my name is Buck Moorhead. I'm an architect here in the city. I also started 6 or 7 years ago with the anti-fracking movement. I got very involved in the Upper Delaware, where it was like there will be blood. People were leasing property up there. This was in about 7 years or so ago. So I got involved. I've worked with Damascus Citizens. My wife and I, Mav here in the audience, we were involved as co-founders for NYH2O, which was one of the first in New York City fully anti-frack assistance group, fully based on anti-fracking. And the thing with being anti-somebody, anti-anything, I've never been an activist before, and I actually don't still think I'm an activist, but is that it's hard to be anti without having a solution, without being able to go and say, okay, so that's a problem. How do you propose solving it? So what I got involved with as an architect was this idea of passive house. And to Bryce's point, there are lots of things that have to happen on many levels, and alternative energy solutions are one of the ideas. Solar, wind, geothermal. But one of the most important alternative energy solutions or systems is actually energy conservation. And what happened in 1990 was that there was a German physicist named Wolfgang Feist, and he took what we were doing in North America in the 1970s. We were doing some really excellent energy conserving strategies in the 70s. He took that and developed this protocol called Passive House. It's a Passive House Institute out of Germany. And he basically looked at it as a building scientist would look at it. And he developed this computer program which allows one to model buildings and have predictable outcomes around what their energy use is going to be. 5 concepts are involved. It's continuous insulation around the building, very thick blanket of insulation, very tight air barrier. The building is tested with a blower door, and they go to they test at 0.6 air changes per hour at 50 Pascal. If we build a good tight building here in this country right now, it has 3 or 4 or 5 air changes an hour. So they're building buildings that are 8 or 10 times tighter than what we're typically doing. But then they also put in heat recovery ventilator systems. So there's fresh air that's continuously pulled through the building, and it goes through a heat exchange, so they get up to 80% of the energy that's being exhausted out is transferred to the air coming in. So you get fresh air that's filtered. The houses and buildings, and Passive House is an unfortunate name, but they're very healthy, durable buildings. They control moisture, the air quality is good. They also have excellent windows, and they are basically thermal bridge free. We build buildings that have enormous pathways for energy to go through the building. And these can be, I'm telling you, all kinds of LEED buildings have these thermal bridges. We just don't consciously look at that in this country. All the concrete slabs that go out for balconies, like tremendous thermal bridge. So they're very simple. It's smart design. There's nothing fancy about doing it. It's predictable. It takes good quality construction. It's like 5 to 10% more to do these buildings in this country. In Europe, they're building them for the same cost as regular construction. They just know how to do it. And so there have been like 30,000 buildings that since 1990, this guy Wolfgang Feist, they're data monitoring these buildings. It's completely achievable now. And the reason this is important is that, tying back to Bryce's comments, was that in our country, 40% of the energy nationally is in buildings. 40% nationally. In New York City, it's 75% of the energy that we use in New York City is within our buildings. And that's because we don't have the same energy in transportation as you would when you're outside of New York City. So the passive houses reduce the energy for heating and cooling by 80 to 90%. Less energy is used for heating and cooling in a passive house than typically. Now in a building, probably half of the energy is in heating and cooling and half of it is in like plug loads, like what you're plugging in. But that, if you can reduce like half of the building's energy by 80 to 90%, you're making a serious dent in what our needs are from pure energy conservation. And then you look to solar to wind to geothermal, whatever you need to pick up your last piece of energy that you need. So this is so achievable, and by 2020 the European Union has actually mandated that new buildings are all going to be to near zero or net zero energy use, and if you can't, whatever energy you need to generate on your own site. So that's 6 years from now. This is like not something that's pie in the sky. They're just doing this, and it's a global movement. There's a New York. I'm on the board of directors for New York Passive House. There's a North American Passive House network now. There are regional groups in California, the Northwest. We're going to a conference tomorrow night up in Maine, which is for the North American Passive House network. It's really fantastic. So that's kind of my prelude. I've got a bunch of slides. I'm just going to run through like really quickly because I want to make sure we have time for Samara to speak and also time for your questions. So I'm just going to click through some quick things, but I just wanted to give you that. You know, you can see the trusses, that image on the lower right. That's the stud wall construction. That's all energy that's being lost to the building. This is the red line and these construction photos. This shows that air barrier, which is very consciously developed. These are the ERVs. These units, in Europe, they build buildings which basically don't have heating systems. This is the HRV. It's a compact system. All those tubes or vents going around the house. This is simple compact structure. It obviously integrates some solar thermal and PV on the roof there. This is a project. The red one is a very famous newer house up in Maine that was won all kinds of awards. This is actually a house we've designed for Habitat for Humanity up in upstate New York.
And you cannot have natural gas in these houses.
Pardon me?
You can't have natural gas in these houses.
You know, we wouldn't do one. This I can click through these. These are plans for that house, that Habitat for Humanity house. This shows like how the insulation. This is kind of the sequence of how the building is constructed. That red is the air barrier, so you're always conscious of where that air barrier is. This is some work we've done looking at retrofitting a multifamily on the Upper West Side. It's a 10-unit building, so we're like showing proposed work that could happen in stages to retrofit this building. Again, I'm just flipping through these again because I want to make sure we have time for.
Is that super expensive?
Yes.
Save the question, right?
More design.
This is a retrofit on Long Island. Showing the construction there. And these are, the passive house name is unfortunate because it's used for buildings which are not houses. And again, in Europe, they're doing schools, they're doing firehouses, large buildings, 354-unit building here. They're doing entire regions or communities that are all passive house.
You say Europe, is that Germany?
Germany, well, it was Darmstadt, Germany. Wolfgang Feist it initiated in Germany, but Austria is a huge adopter. Belgium, it's all through Europe now. And China, they're building plenty of skyscrapers in China that are passive house skyscrapers. It's a global kind of cult movement. I mean, there are a bunch of projects in Brooklyn that are underway. This is happening like right now. There's a woman in who's a New York City architect. She's planning a 40-unit market rate project that's a rental building that's going to be on the west side of Manhattan. And it's to the point about gas for heat. They're looking at putting electric heat for the heating system because the heat level is so low that they don't need to have a gas-fired boiler. You know, because it's basically you're providing heat for your worst case scenario, but often, you know, throughout much of the year you need no heat. So this is, again, just looking quickly through here. I think I'll just leave it there and leave some time for Samara to talk, and then we can have some time for questions.
Okay, great. Yes, Samara Swanson. You're next. Samara is the attorney for the New York City Council Environmental Committee, and she is, you know, going to have an incredible talk. I heard her last night at another talk, and about the Mothers Project, and that was a conversation about what's happening with children. She definitely has some important things to say.
So I'm supposed to talk about renewable energy and initiatives that the City Council is interested in advancing. I would preface this by saying we're about 25 years late in doing this. EPA said in 1988 and 1990 we had to reduce our fossil fuel use 80% of the 1990 levels to stabilize climate. They asked Congress if they could get permission to address greenhouse gases. Of course, Congress said no. And it wasn't until they were sued in Massachusetts v. EPA in 2007 that the Supreme Court said, oh yes, you can address greenhouse gases, and you always had the authority under the Clean Air Act, the 1990 Clean Air Act. So here we are now. It's too late to stabilize climate. And now we are looking at what we can do to avoid the worst impacts of climate change. Congress is still saying no today. We can't get any agreement. But the purpose of the march tomorrow is to see if we can get the United States to play well with the other countries in the world. Because it's a global problem. It's not just a United States problem. But make no mistake, the United States is responsible for the most greenhouse gases in the environment. We're number one. We may not be number one this year. China surpassed us on an annual basis in 2007. But cumulatively, we beat out everybody else in changing the climate. And the greenhouse gas emissions, including the methane that we put in the air, is going to be there. Methane, at least for 50 years. The CO2 emissions, thousands of years. So what can we do now? Well, one of the things we can do is use some of the resources that have always been available to heat and cool our homes and generate electricity. So it's so funny that when I researched this, I realized that in 1888 we were generating electricity from windmills. 1888, and now we're looking back, going back to the future, and doing the same thing again, generating electricity from windmills. Also, people can remember President Jimmy Carter. He put solar panels on the White House lawn. That was in the 1970s. This isn't new technology. So all the technologies we need are here now. And finally, geothermal. About 50 years ago, they were using geothermal ground source heat pumps to take the solar radiation that is captured in the shallow layers of the earth and bring it into our homes for both heating and cooling. Cost to actually use the energy, zero. So if we were to put solar panels on our roofs that could power the compressors that we need to generate heating and cooling through geothermal, we could be not on the grid, and we could be sending power to the grid. So in places like Arizona, people get checks back from the utility company for generating electricity on their roof. How, would you say not anymore? Again, we own it, we can change it. So that's the other message I want to bring out, that they keep telling us these things are too expensive or these things can't be done. There were more of us than there were utility companies and corporations. And we own the property, and we own the future, and we have to take it back from the corporations if we want to have a future for subsequent generations. It's us. They can't tell us it's too expensive. Let them make it cheap enough for everybody to join in. We need everybody to take us to the future. So, I want to say that, yeah, I was in the EPA. I was very proud when they went to Congress and asked for permission to address greenhouse gases. Now people at least recognize that it's a huge problem and we have to come up with a solution. Let me just say something about the public health list. It's gigantic. In New York City, 3,400 people die every year from poor air quality. According to the New York City Department of Health, 3,000 or 4,000 children are hospitalized every year due to poor air quality. Of course, we had Sandy. We had significant damage to houses, 4,000 houses destroyed, $30 billion worth of Sandy damage. And of course, we are anticipating in the future sea level rise. So the Mayor's Office of Long-Term Planning and Sustainability has said that sea level will rise 55 inches. So that's about a little taller than me. Lots of New York City is below that level. If we want to have a sustainable future, we have to plan for it. So there are a couple of things we need to do. Of course, we need to change to renewable energy. We need to develop better forecasting skills so we can know what to expect. We need a backup plan when we aren't able to keep temperature levels below 2 degrees Celsius. The goal of the summit, of course, is to keep temperature from rising beyond 2 degrees Celsius. So 3.6 degrees, we're talking about temperature that would be 61 degrees worldwide on an average. But we're on target to go up 4.6 to 6.6 degrees Celsius this century. So that's like a world that's 10 degrees hotter. That would knock out our ice sheets. The Greenland ice sheet alone would be 23 feet. All of our ice sheets would give us Water World. For people who can remember that movie, one of my favorite movies, it wouldn't be great. We may be able to avoid that if we transition. So we could maybe avoid the worst impacts of climate change. So, but we don't want to, no one wants to give up their energy use. Nobody wants to even unplug their cable box or have anything different. And so we have to use renewable energy. The New York City Council has a couple of bills that we are looking at that will help us make the transition while Congress says no. The first one is Intro 378. This would call on us to reduce our fossil fuel use 80% by 2050. And that will require transitioning to renewable energy. So right now we have a bill that says we have to reduce our fossil fuel use 30% by 2030. Obviously that's not aggressive enough. And we are not exactly on target to meet the New York City goals with that. We're going to have to do much more. With solar and geothermal, obviously we could do much more. We also have the issue of transportation fuels. So what are we going to do about transportation fuels? And New York City Council has bills before us in which we're requiring our ferries to increase use of biodiesel. So it's going to go from 5 to 10 to however much it can run effectively on. And it'll come from soil, it'll come from chicken fat or beef tallow or wherever it can get it, that doesn't involve importing more oil or digging up the ground. So we would get New York City DEP Marine Fleet to use biodiesel as well. That's another bill we have planning in the introduced stage, Intro 54 plus Intro 451. And finally, we have a bill that would require solar photovoltaic on New York City buildings. New York City spends almost $1 billion a year in electricity. That's a lot of check.
Wow.
But we have all these buildings with the sunlight falling on these buildings, and they aren't capturing it in solar photovoltaic. So we have a bill that would require solar photovoltaic on New York City roofs, and we could take that $1 billion that we're giving to utility company and use it for education and health, preparedness. So these are the things that we would do to bring about change. Of course, we're looking at offshore wind installation. New York City Council passed a bill that looked at in-conduit hydro. So there's hydro that is created by, hydropower created by building dams, harms the environment, and hydropower created in conduit, in the existing pipelines that transfer water, does not harm the environment. So in Denver, Colorado, and places like Keene, New Hampshire, and other places, they're generating electricity inside of the water pipes that they use to transfer water. And I understood in Keene, New Hampshire, they actually got a check back from the utility company by using in-conduit hydro to distribute their water, something that every municipality has to do. And New York City has already implemented geothermal in a number of building applications. One of the best ones I've seen is the Weeksville Center, which is in Brooklyn. You go in this building, and if you get a chance to see it sometime, you can step from the future to the past. They found the 4 original homes that were part of the Weeksville settlement of African Americans in Brooklyn after the 1860 draft/race riots. And those original homes were purchased, and in the center of there's a sort of a meadow in the middle of the block, and that's where they sunk the geothermal wells. And the geothermal then is taken into the museum, which is fantastic and well designed, and they can just cut off the power in different parts of the museum when they're not using it. When you go downstairs to look at the energy generation, you're going downstairs in a basement that's clean, no soot, no dust, no boilers, no boilers. And there they'll show you how they just switch a wire, and you can either get air conditioning or heat by just switching a wire. And the person who manages the system on his cell phone can do it off-site at his house, and he can just change the temperatures. The system is so sophisticated. I was loving what you were saying, because it takes in air at night depending on how cool it is, and then it determines how much cooling is needed during the daytime based on the ventilation system. So it's all done by computer. And so you can go there, and then you can go to the past where you see buildings that had no boilers and fireplaces, and in the backyard they even have a little farm where they're growing their own honey. They have little beehives and stuff like that. So it's a nice experience. Well, we need to step from the past to the future. We don't have a lot of time to do it. So if we don't get it done in the next 25 to 50 years, I can't speak on what the future's going to be like. But if we stay on the business as usual path, I don't know what life will be like in the next century, but it's not going to be good. I don't like the movie Waterworld's Ramification. I don't want to see the road either, where we all the plants and animals are gone. So it's up to us to take leadership now and not listen to it's going to be too costly. It's up to us to make a difference now, to tell our elected officials, ask them where they stand on fossil fuels, ask them to take a stand for renewable energy. And if they don't want to do the right thing, you know what to do. Wall Street too. So all I would end with is we can have energy independence. The technology has been here for about as long as I've been alive, maybe longer, but only if we insist. The greatest risk to our future, the future of our children, is continued use of fossil fuels.
Oh, goody. We have tons of questions. This is great. How about you? You've been trying.
I have questions for him. Are you aware of Boulder, Colorado's carbon tax? And they're using it to buy their transmission lines so they can get into the regional electricity markets and determine really what type of electricity is coming into Boulder? This would be really
proposed a
cool.
carbon tax a few years ago under, and a carbon program under Bloomberg. Of course, it was shot down, but we're going to come back with that. And in fact, Chair Richards has a resolution asking for a carbon tax. Boulder, Colorado's ahead of us on that, but yes, we're on the track.
Buy your transmission.
Yeah, I don't know what your connection with children's health issues are, but I'm a physician and I'm involved in a fight to stop a pipeline that Governor Christie wants through the Pinelands to repower the oldest coal-burning power plant in the state of New Jersey, VL England. And I did some research, and I have some friends that are involved with epidemiology, and it's a real concern that the ultrafine particles are in fact more dangerous than the larger size particles emitted when burning coal. And this is a case of leaping before looking, because the children are the most vulnerable with the emissions from burning frack gas, potentially. And I really believe that's so. Is there any research to bring out the actual health impacts of ultrafine particles? That's what I've been trying to bring up.
Absolutely. Yes, we have.
Do you have that resource for me? Because that's something we're trying to stop this pipeline through our pine lands, and then we are downwind in Ocean City from the emissions of this. And the EIA is the one in their earlier report talked about this being a real potential danger. Yes.
Do you want to answer that?
No, go ahead.
Yeah, I spoke to Barbara Arundel at Damascus Citizen. She's the director there, and I do have links for some of the studies, but it is, number one, it's not measured, it's not been acknowledged, it's not something that we constantly know about, but she told me that definitely it is dangerous. And if you give me your email, I can forward you.
Oh, no. Yeah, how about up? Can you put it up?
For everybody.
I don't have it here with me.
No, I mean on your site, can you?
I will, yes, that would be a great thing. Go to the Damascus Citizen site, we'll have it put up. There's also, on the Damascus Citizen site, I believe it's still on the front page because we've also been doing a climate change thing. There is a compendium that Larissa Durska, Sandra Steingraber, and Kathy Nolan have put together a 70-page document. It's called the compendium, that includes all of the health impacts that they've had studied from natural gas use and fossil fuel, all the soup to nuts of the
It's from
natural
the
gas.
shale gas extraction, but not from the burning.
Well, it'll include as much as they possibly have available, and it's a very big study. And so you may be able to find some things about that there as well.
Because where the fracking is, we know about the defects to the children born and so on and so forth. But the big black hole is really
No,
the
this is a very
emissions
good
from
point.
burning.
It is something that has not been addressed.
I know.
It hasn't been addressed. It
We
isn't
don't
measured.
even have a good methane number. Now you're asking for numbers on what happens when you burn them.
And is it 2.5, is it less than
I know.
2.5? Like what, if we get monitors on these suckers, you know, is that?
2.5 of what?
Is that, if we get the microns, is that gonna be a good monitor?
The government regulated PM 2.5 some years ago, based on a number of studies, EPA. But the more we find out about risk, the more we find out that lower and lower numbers can present risk to children. I totally agree with them.
It's the same PR firm that did the tobacco things I
Yes.
found out.
Bill and Knowlton.
Yeah, they're the fellas.
This
What's
work,
that
this
name?
work has been done in Seattle around a group of physicians led by Frank James. He's come to Canada, I'm a Canadian, and he's given talks on this particular thing, right? So
Does he have some conclusions
I
about
could find the stuff online, and if you give me your
I
email.
will, thank you.
Send it to Damascus, I have it.
Could I, yeah. I'd like to-
Okay?
Also,
But
Yeah, we need to send it.
Because this seems to be a good way to fight this bringing to retrofit, you know, coal-burning power plants and other kinds of this clean energy.
NRG just announced that they're going to comply to the EPA carbon rules by closing one coal plant down, switching to frac gas on another. So it is definitely happening already.
Oh, I know.
They're implementing.
And even right now, they're as you all know, they're programs to switch people on to using natural gas-fired or gas heaters in their homes. You get incentives for doing that. And so, like when you talk about that picture right there, the answer should not be fix the leak; it should be cut off the supply. Do something different.
So that's what's going to be the problem, because, you know, the energy has money and they can push it through and they can
I mean, if you're going to be using natural gas, yeah, you should plug these leaks. But the answer really needs to be, don't have this network, don't rely on this network for your home heating.
Why use
One of
fossil
the-
fuels when we have to walk away from it?
Yeah.
There's no choice, but we have to walk away from it. We have a very short relationship with fossil fuels in mankind's in recorded history, thousands of years, a couple of hundred years of fossil fuels. We can switch. We have the alternative.
Can we talk about the shale gas, peak shale gas, because this is really important right now. You know, TransCanada and Canada and everything, they're selling the switch to frac gas because it's reliable and we have so much available. But what's the reality? Is peak shale gas really 2017?
This is a question that Bryce should answer.
Yeah.
Not really, but I'll give it a try. The issue of peak shale gas is a bit loaded because no matter what you do, you get to the same result. The fact of the matter is that a lot of these shale gas wells will peak relatively quickly. They all do. I mean, it's just the record is there. The thing of it is, though, is that they can then go back in and refrac. And they can refrac and re-stimulate that well. Each stimulation is a little less effective than the ones before. So the idea of peak in 2017, they're drilling more wells all the time. Peak in terms of all the shale gas, probably not. Probably not 2017. They can go longer. There's plenty of shale out there that hasn't been fracked yet. The difficulty is that from my perspective, the more fracking that's done, you can't unfrack this stuff. Once it's done, it's done. And there's no going back. And let's say even a small percentage of these wells, the fracking causes a connection between natural geological pathways and the surface and the frac zone. From that point forward, that pocket of gas is a pocket of gas and now it's connected directly to the surface, or even indirectly to the surface, doesn't matter. The methane is coming up. So when you get to the peak, I don't know, let's say 150 years from now. The problem is that peak can't be stopped.
We won't be here.
We won't be here, which is another
Our
point.
species will not be here.
Samara brought up, and the issue, and you brought up in terms of the children. It is the children. It is the children. Stop talking about yourselves. It's the children.
He's talking about the end.
We're gonna see it too. We're gonna see it.
There's a woman named Deborah Rogers, who's an analyst who has done a lot of study and has a lot of reports on these. Deborah Rogers. If you look up her website, you will see her discussions of depletion rates And there was a talk you did here in New York about 6 months ago that talked about that. And for example, I know that there's a county in Pennsylvania that has actually stopped doing wells there. I'll remember the name of it in a minute, but it was, you know, they keep saying that, you know, like maybe it's 6 years, maybe it's 10 years, even though, you know, the government has been saying it's 100 years.
Well, it becomes a lot less too when you decide, as a matter of government, federal public policy, that the best thing to do is to ship it out of countries, to put your own resources and ship it overseas.
Well, they're trying to do that, yeah. If we run out of things and we've had contracts with these other countries, this is going to make it a whole lot more messy.
But there are a couple more questions.
One question about the methane that's going to be emitted by the swamps that are under from the permafrost.
Okay, so that's a great question, the tundra. Once this process starts going, and it has started, right, and again, we're responsible for it. The tundra is going to start emitting a lot more methane. We won't be able to stop that. And so we shouldn't be having a discussion about how much gas or oil or coal we have left. We can't use it. Even if they find 100 years, 500 years, we can't afford to burn it. So let's change now before we do more damage to our precious resource, the planet. There's no plan B. We only have one place we can live. So it doesn't matter if they found a 10 years coal, 50 years, 100 years old, peak oil, none of that matters because we can't use it. And what we ought to be doing is keeping it in the ground. Now, whether it costs resources, whether we've got to pay states to transition places that are, and states that are cutting down trees, whether we need to pay them, whether we need to do a national assessment of our natural resources to figure out what we need to keep for the future. But we can't use all the fossil fuels they can find under the Arctic Circle or anywhere else.
Is there any?
We have another question. Yes.
I just wanted to follow up with this methane thing. Aren't we in a race with CO2 that's going to melt the ice caps and create this methane?
There's what's called a potential positive feedback with methane. And that is if the temperature climbs too much, or if the heat distribution because of a temperature climb is such that you heat the Arctic, permafrost melts, and conceivably you could cause ocean currents to start decomposing methane, called methane hydrates, in the bottom of cold water. If those things happen, it's Katie bar the door. Nobody knows when it's going to stop. Because once the methane starts rolling out, methane, somebody was going to ask earlier about how you can decompose methane in the atmosphere. Once the methane starts rolling out, it overwhelms the ability of the atmosphere to decompose it. And so then it just accumulates faster and faster and heats more and more, and it just goes on and on. And once you lose control, you can't get it back.
Aren't we? Isn't it starting to happen?
Yes,
It is starting.
Yes.
And so we're in a race to what? I mean, I don't understand how just eliminating methane from our own use is going to make much difference. If the CO2 level is melting, the ice cap.
I think you're asking a perfectly reasonable question. I am, in my heart of hearts, my opinion is prepare the children. Just prepare the children.
For death?
No. I don't think this is going to be. I don't think this is going to be the end of mankind. I think this is going to be a transition from one cultural notion to a completely new one, and it may not be nice. Probably won't be. An issue that's going on with the 2 degrees C, the average global temperature change. We're talking substantial agricultural impact. Food production is going to be a problem. Our food production right now is utterly dependent on fossil fuels. If you try to cut fossil fuels out of agriculture, our agricultural production will drop substantially because we're very dependent on fertilizers, and they all require fossil fuels. In particular, our use of nitrogen. The thing is going to unfold, and I hope very much that my perception is wrong. I would love for shale gas to be something that we could use and have all of the benefits that are claimed for it. It's just that what I see is that it's not the case.
In the far back.
The woman in the red shirt.
I just wanted to point out that when we talk about, to me, the importance of the whole idea of the peaking and I've read things that suggest they're lying pretty hard about how much shale gas there is. Yeah. The thing is, if we are going to stop burning huge amounts of natural gas in our houses, then we have to start doing those passive houses, and we have to start doing it on all of them now. We have to retrofit with them. We have to stop burning the fossil fuels for electricity. When I moved to West Virginia almost 40 years ago, I lived for 2 years without electricity. I used kerosene lamps for light. Kerosene lamps suck. They stink. They have these, you're always having to adjust the wicks or they burn off.
And they burn fossil fuel.
And they burn fossil fuels, so they will run out, and they're a fire hazard. Now, I still live in West Virginia. We have 4 solar panels that provide all our electricity. And we use 3 kilowatt hours a day, more or less. That's 10% of the U.S. average. And you know what? I think we live pretty well. I think we could all cut down to half overnight. I think we could cut a whole lot more down. But if we don't start using the fossil fuels to build out the infrastructure, to create that insulation, to create all the other materials for the passive houses, to build the solar panels and the windmills and the batteries, then we will be burning candles. Because the windmills and the solar panels that exist now will not be able to pick up the slack to create new windmills and solar panels if they're expected to do what they were doing and pick up the slack of the fossil fuels when they dwindle. So we have to make the conversion now, or it's back to horses and candles.
Which gets back to the question of why try to do anything with methane? Methane is a minor component of the whole thing. Working very hard on methane slows the curve down. Only briefly. Let's say it takes 20 years to bring methane under the highest level of control we can get. Let's say we cut it by 80% in 20 years. There's no place else to go on methane after that. In that 20-year period of time, you better have brought CO2 down. You better have used those 20 years to do what has to be done with the CO2. Because if you don't, you've frittered the whole thing away. That little curve in the benefit of methane in the beginning will be gone. But it's the only thing out there that I see right now that's offering any ray of hope.
Right. No, I understand.
Yes, ma'am.
So, Buck, you had mentioned conservation, and the way that we changed the society when you think of smoking and seat belts, and that we really got these major changes, was a lot through getting this information in the schools. And so there's a movie that's going to be shown, at least little clips of it, at either 2:15 called Dreaming in Green, which is about these kids who, in middle school, who did an energy audit of their school, and they saved their school $53,000 in energy bills. And so, the idea is, you're talking about the children, getting this into all the schools where the kids are learning about what you're doing. That should be part of the curriculum, right? And I wondered, is any of this, do you know of any of what you're working on that is part of the curriculum? And if you do, I'm the producer of these movies, Young Voices on the Planet. You can watch them online. But we are incorporating these stories that get into all the schools and can make this happen through the kids bugging their parents.
Yeah. Any other questions? Marge, yes.
I guess for Bryce, I was curious, they were talking about the methane study and methane leakage, and they didn't say, something was said about the Arctic methane leakage. Could you, because they said we haven't quantified it yet, could you further, about the permafrost? It was like that was a minimal concern, and I was kind of surprised by that.
No, it's not. What's actually going on right now is the current data says that currently the Arctic is not a source. It doesn't say the Arctic is not going to be a source. The current data says currently it's not a source. The current sources appear to be tropical wetlands and fossil fuels in basically North America. North America and Russia. That's where it all comes from.
How about the most recent findings of the big crater in
Yeah.
where methane is massively released in
By the Russian research.
Arctic methane emergency.
The problem with those is it's just like these. When you get a massive burp of methane, if you're not there when the burp happens, you can't retrospectively measure it.
Right, but those things are happening.
Oh, yeah.
Obviously, got one crater like this.
But the thing, if you look at those craters, the thing is that people, when you get something of notoriety, people jump on it. I saw one image of one of those craters, and they pulled back on the image, and when they pulled back, there were lots of those craters, very old and sitting out there.
Are we done?
Yeah, thank you very much.